So we have two great speakers, like all our other speakers yesterday and today. We have Matt Jones on your left, my right, who's a professor in the history department. Can you hear me? Oh, yeah. All right. On my right, on your left, Matt Jones, professor in history. On my left, on your right, Chris Wiggins, professor in applied math and applied physics. Matt and Chris did an amazing thing. They started a new class last year, and it's called Data, Past, Present, and Future. And it started as an experiment, and they are teaching it again this year. And we thought it would be a great way for us to learn about what the class is about. It's very relevant to all the themes that we've been talking about during the retreat. And they're going to give us a 1-hour summary of their class, basically. And they're speaking in particular about data literacy and ethics. Thank you, guys.
Thank you, Noemi.
Thanks so much.
Okay, so Noemi encouraged us to come up here and talk about our class. We hope that this material is of interest to you. As Noemi emphasized, this is an experimental class. I should say it was generously supported by the Collaboratory Fellows Fund at Columbia University, which made it possible for us to do something as transgressive as teaching a class with faculty from 2 different schools.
Non-trivial.
Yeah. So the class is an experiment. And so the experiment starts with a hypothesis. And the hypothesis is that there's material that's not being taught to students, neither to the technologists nor to the humanists, and yet material that is going to be very important for them for the coming century. Material about how data is shaping their lives and data-empowered algorithms are shaping their professional and political and personal realities. So that is the hypothesis, is that we will be able to carve out material that is not duplicative to things that are existing in canonical curricula, and yet that we think is really important for all citizens. So in order to present this to you, we will show you what day 1 of the class looked like. We'll just burn through the slides from day 1. And one of the things that we think is most missing from curricula is ethics. So we're going to talk about what we talk about when we talk about ethics, and how we define ethics and try to operationalize it. And we'll use ethics as it's understood in the research community as a backdrop for ethics as it's understood in the real world. And then we did this in a way that leverages heavily technology. So discussions are happening in Slack, and every day there's a lab. Every week there's a lab. So we will show you our Python notebooks. I encourage you, if you have laptops right now, you can go to GitHub and you can slurp in all of the lecture notes and labs right now. They're all IPython notebooks in Jupyter notebooks in Python, so we'll show you that as well.
Yeah, just one bit of contextualization. The class is intended for undergraduates at Columbia University from all 4 of the undergraduate colleges, and we very much hope to leverage the different skills of the different kinds of undergraduates throughout the class. So we have a certain amount of presumption of not so much of background, but of a serious sense of purpose of both technical and non-technical students.
Okay, so the hypothesis I've presented, that there's important material and it's being taught neither to the future statisticians nor to the future senators, and that we can leverage what we call multi-capabilities. That is, when we say to people, you need to understand data, to some part of the citizens, it's useful for that they know how to open up Python and slurp in data and do some statistical analysis. To some subsection of those people, it's also useful for them to know how to use the results of some statistical analysis to advance some argument. That is, it's not a dry, bloodless act where somebody gives you a data set and says, make me a histogram. The usage of the histogram or what have you is in the service of some particular worldview, and you are arguing for that worldview with your statistical analysis. So that's a type of capability called a rhetorical capability. And everyone is going more and more to be subject to other people making arguments with data. And so we also want to teach people some critical capabilities. When somebody makes an argument to you and they use a graph or they use an AI model to argue in behavior in advance of advancing that worldview, we want students to have critical literacy or critical capability to critique that argument. The other thing is there's a lot of context around these technological developments, and rather than sort of pair that off and pretend like the context doesn't exist, we wanted to really engage with the political background that advanced each one of these technical capabilities. We'll talk about we taught it as a history class, so we teach technical capabilities in order, and how each one of these technical capabilities rearranged power. And that idea that a capability rearranges power is a direct reference to this essay from Rogaway, the cryptographer. So after the Snowden revelations, Rogaway, who's a pretty mathematical researcher, wrote this essay about cryptography, and he said, cryptography rearranges power. It configures who can do what from what. And I think we would both make that argument that can be said about almost any capability, and in particular, data science, data analytics, building AI, all of those capabilities rearrange power. It reconfigures who does what. Okay, so the student I view is to present to you lecture 1. So what did we actually say to students on lecture 1? So the first thing that we did was some paid marketing. In some ways, the lens of the class is how did we as a species get to this point in 2018 where data-empowered algorithms are shaping our realities? And so we did some reality shaping by going to Facebook, and I went to Facebook and I made a sock puppet, and I gave that is a fictitious account, and I gave that fictitious account my real credit card and gave Zuckerberg some real dollars and paid to put this thing in the feed of people who were potential students. So I did a bunch of marketing using what Facebook calls the power editor. So if you've ever used Facebook and somebody said to you, oh, there's a thing in Facebook called the power editor, you might think that that's something for helping you edit your posts. Oh, it is not. The power editor is a marketing tool for people who do paid marketing to do extremely personalized targeting. So we did that. I put this in the feed of people who are potential students. Actually, one of my own students saw this in his feed and sent me this screenshot. So it's a very meta thing, why did it be featured? So this is what a power editor looks like in Facebook, where you can go and do A/B testing to figure out how to optimally target people. So I showed the students this is how I targeted you. This is how much I paid for every one of your clicks. So students get a sense that every time they're clicking on something, money is changing hands. And also students get a sense for how much people are investing money and technology and energy and data science into targeting them and shaping their reality. I showed them how you can go and target them based on things like their interests. So for example, I might target people who go to Columbia University and are also interested in flat Earth. Facebook will tell you that there's 2,000 to 6,000 people of them, and if I pay Facebook money, they can make 20 to 100 people click on it. And then it gives some detailed demographics about who these people are. So again, this was, I don't know, this probably would have had a different tone if we did it after Mark Zuckerberg had testified to Congress, but even in January, this was kind of amazing, eye-opening to some of the students that their eyes and their attention is valuable, and you can easily put a dollar value on what a click from one of those people is worth.
So I did the same thing on Twitter, and I asked Twitter to help me extend my reach. And Twitter was enormously helpful in doing this, in allowing me to have a vast number of impressions. And I thought this was very impressive, and it cost me a fair amount of money until I discovered in a matter of several seconds that I had gotten 5,638 impressions from Indonesia, all from Android devices. So in the process of doing this, not only did we have our reach extended, but we were in fact scammed by social media companies. Indeed, when Chris looked at the Google Analytics on our site, we found...
So just to show them just how much systems work is being done to command their attentions and shape their realities and persuade them of things. We did Google Analytics as well, and so with Google Analytics you can do some forensic accounting, and you can actually audit what Facebook says you got and what Google Analytics said you got. Do they agree in terms of how many eyeballs are coming from different countries?
And the value placed on each of those impressions from different countries.
Yeah. So for students who have never seen paid marketing before, everyone has seen paid marketing. For students who have never done paid marketing before, this is kind of amazing to see just how much architectural work and how much data science goes into every single thing that they're seeing every day, all the time. So then we can pose to the students, how is this possible?
And we really had the advantage of the fact that we had this heterogeneous group of students. We had everyone from humanities graduate students using impenetrable jargon to technically minded machine learning students using impenetrable jargon of an entirely different kind. And so we asked them to just shout out what are the conditions under which this is possible? And they came up with all kinds of things.
So a CS major said, well, you need the iPhone. And then another student said, you need neoliberalism, which I thought was a great rendering of like how heterogeneous the student population was. And of course, they're both right? To get, this is not just a technology problem.
And it suggests the challenge that we've assigned ourselves, that to understand the conditions of this and the ethical and political choices, we needed to understand both the iPhone and the constitution of liberalism, the creation of the technical practices as well as the engineering practices behind the iPhone and the changes in market and in the global public sphere that was necessary. So this was our challenge.
So then we turned from our own slides into a wider discussion among technologists and humanists about the raging dumpster fire that is our current information landscape. For example, Arvind, who's just called by his first name, who's a CS professor at Princeton, has done a lot of great work over the years. When he was still a graduate student, he did the re-identification of people in the Netflix challenge, which is why there never was a Netflix challenge 2. And more recently, he had been showing that a lot of the JavaScript that people are using when they go to websites is recording every single keystroke. So like every character of your password is being logged. This just amazing full surveillance at the level of keystroke at scale. And then, of course, other artificial intelligence researchers, including at Stanford here in the business school, had been writing a bunch of provocative papers, including this one, arguing that you can use AI to figure out if somebody is gay or straight just by looking at a picture of them. This work has been widely critiqued for a variety of reasons, particularly ethical reasons, but there were also really good technical arguments against that. So just to enumerate the authors, Michael Kosinski, who's written several papers of inflammatory nature using AI. We also introduced them to this work from several summers ago from ProPublica, doing a deep statistical analysis of algorithms that were used to assess possible recidivism of people accused of crimes, and then judges use these algorithms to inform their decisions.
And then we introduced a very recent paper on using inference on criminality using face images, which had this rather striking quote. In all cultures and all periods of recorded human history, people share the belief that the face alone suffices to reveal innate traits of a person. Interestingly enough, this paper doesn't challenge this, this long-standing view, but rather leverages it. And that brings us back to history, to the 19th century, to the hope that there could be a scientific criminology, which would allow us to remove all of the social forms of crime and understand those who are truly criminal through the inspection of physiognomy or other human characteristics most associated with the character Lombroso. And it is precisely by pushing back in time that we can understand the constitution of a lot of the moral and political and ethical choices in the constitution of new technologies, particularly quantitative technologies, from the origins of what we would think of as state statistics in the late 18th century forward.
Getting back to technical arguments about this, a series of researchers, including Google researchers, had written some great papers trying to help us all parse what's new from what's old, which I think is useful because you see something like this that just seems shocking, and then if you really want to take a scalpel to it, one useful scalpel is the technology and another is the history, and to separate out what is new about using AI rather than using multivariate regression, and what is very, very old in hoping that somehow numbers are going to scienceify our biases. Okay, so in fact, this was an essay that started out saying there's many, many ethical problems with this, but for the moment, let's talk about some deep scientific problems with that. And as I said in this paper, like computers are the internal combustion engine, AI is a general purpose technology that can be used to automate a great many tasks, including ones that should not be undertaken in the first place. This line and this particular usage of the word technology is something we try to advance or explore in the whole semester. So we try to explore the idea that a technology is a thing which separates a capability from an intent. And so you give somebody a hammer and you think they're going to use that capability in order to build a house, but maybe they're going to use it to destroy a house. And many of the things that we create throughout history as technologies are themselves algorithms. And people might do things with those algorithms that the creators of the algorithms did not intend.
So one of our major arguments throughout the class is to show the students and make them reflect, and indeed to make them see the ways in which the statistical science have always been political. From the early 19th century, the sciences of social difference have been central to the development of statistics, and more recently, the data scientists. And this is a through line in everything we do. We give an example of that got a lot of play in the blogs not so long ago about some of the remarkable data visualizations that Florence Nightingale did in the middle of the 19th century about the public health outcomes for British soldiers. And indeed, she produced these extraordinary data visualizations showing for a much more general public the need for public health reforms. But these were intimately connected to questions of British racial superiority. So she writes, upon the British race alone, the integrity of that empire at this moment appears to depend. The conquering race must retain possession. So every week, we try to combine, and I say try because this class is doubly experimental. It's experimental in content and in form. So we try to combine the scientific and mathematical developments of a particular moment, say the 1830s or the 1980s. We try to combine the way that those are made into forms of technology in which capability is separable from intent. We try to look at the driving forces, money, prestige, resources, imperial competition, and we try to look at the way power and ethics are involved in this data-intensive knowledge. So we broke roughly this genealogy of the development of the data sciences into an early 19th century period, which is the first birth of mathematical statistics and the accumulation of state and other sorts of statistics, characteristic of famous people like Quetelet, Galton, then Pearson. We look at the sort of mid-20th century moment, which we think of as data and engineering, and then a much more contemporary moment when these data-intensive practices and algorithms are embedded in large-scale technological platforms. When talking about, we do talk considerably about the math and statistics, but we also want to talk about the way these are embedded in systems of statistical combination. Yeah, so we also use a lot of memes. I mean, we have to communicate with the students at their level. But we're interested both in sort of a mathematical story, but also a story of data, and a data that isn't disembodied. The creation of censuses and government surveys are huge state-driven projects that involve the creation of new information technologies like Hall Earth machines and other sorts of things. And that presages the development of an always-on network infrastructure with the sensors that make possible so much of what concerns us and excites us now about the data sciences. So throughout this course, we focus on the intertwining of power and capabilities. And we ask the students to look for a large series of questions. One is a set of questions that has to do with, ought we to organize our social and political order around the best knowledge that different scientific disciplines could produce? There's a long line of statistical thinkers who think what we need to do is transform the moral and political sciences and the economic sciences to accord with the best science. We also ask how, in fact, did technologies transform the social and political order? And, very pressing for today, how do technologies augment and diminish democratic and authoritarian orders?
Another way of talking about this is politics, and I tried to emphasize to the students that politics doesn't necessarily mean going to vote. It means the dynamics of power. Every time we have a new technology or new capability, these are first available to people who are in power. Another way of saying that is the quote, "The future is already here, it's just not evenly distributed." So how does this distribution of capability reorder power? At some point, somebody gets access to data about all the state, or at some point, somebody gets death tables, and then they're able to have insurance. At some point, somebody is able to create multivariate regression, and they're able to predict things in a slightly better way than somebody else. How are the data-empowered algorithms an example of this dynamic? So we live in a world of data-empowered algorithms. How do we continue now in modernity to carry out this repeated pattern or anti-pattern? Okay, the intellectual arc of the class. So we have to choose a starting point, and we have to get to today by the end of the class. So as a starting point, we choose the first usage of the word statistics. And it's fun to take that first usage because it didn't have anything to do with data. When people started talking about statistics, they meant the state, which is why stat is in there. And in fact, statistics, as I heard Matt saying to somebody at lunch today, was about understanding the state and not necessarily about quantifying the state. When people started actually collecting data about how many cows you have and how many acres, that was called vulgar statistics, when you started reducing statistics to something with numbers in it. And then, as Matt indicated, late in the 1800s, early 1900s, you see the rise of mathematical statistics as academia takes in statistics and tries to give it legitimacy. Regression and hypothesis testing are promulgated in the first half of the 20th century. And then a major break point happens at World War II when data starts getting put on, well, when we have digital computers, and one of the first things we start doing, we as a species, do is start giving them data. There begins a debate around intelligence, which is sort of an academic exercise that rapidly gets taken into industrial and military concerns. We show them the first birth and death of AI. We talk about the rise of machine learning, and then in this AI renaissance, we talk about the way that artificial intelligence is being leveraged for you and against you. Again, we see World War II as a huge breakpoint, particularly through the introduction of computation. And we see different powers advancing the use of data at different times. Statistics begins with statecraft, so it's a governmental concern. Mathematical statistics is a time when academia takes in statistics and tries to make it real by making it mathematical. There's a lot of military usages that really drive forward computational use of data in ways that don't get outside the fence for several decades. In some cases, it took us a half a century to find out what really went on at Bletchley Park in the UK. And then industrial concerns start really advancing machine learning in the 70s and 80s, and particularly today in a world where .ai is ruling so much of our experiences. So we go from statecraft, warcraft, academia, signals intelligence, data wars, including wars over who's going to get funded, which is part of the AI story, is the story about who's interested in making sure that the money flows to themselves, and then surveillance economy. The persistent operation is that we teach it as a history which allows you to build capability on top of capabilities, but every time you introduce a new capability, it's really fun to see who was pushing for that capability to be created, and once that capability had been born, who benefited. So that is to say, all of these capabilities rearrange power. That is political. And of course, we also want to explain to them how did that thing end up in their newsfeed.
Just back,
please.
Just one thing about part of the reason we do this in a historical vein. These developments from the 1770s up through World War II, there's a rich literature in the social sciences investigating, thinking hard about how these transformations and how to think about them as epistemic and political ruptures. We don't have that same kind of literature really for more recent material. So giving students a competency not just in, say, some basic statistical measures, but the way in which historians, sociologists, and anthropologists of science have thought about what those changes meant and what they meant philosophically as well as sociologically gives students tools that allows them to combine functional and critical literacy later on. And so we give them some very challenging and sort of hard works on the epistemology of statistics in the 19th century. They really run with it, and then it provides them skills that they use later.
So we open up the class by sort of introducing them to challenges and to think more deeply about the reality that they are experiencing and how that reality is constantly being shaped in the palm of their hand by data-empowered algorithms. There's a bunch of great recent literature to help them think more deeply about it, including from colleagues down the street at Microsoft Research in Chelsea. And then, like I said, we try to go way back to the first times that people start keeping just records of how many people died every year based on when they were born, and we see how that has financial advantage and throughout, particularly in the early days of using data, it really challenged people's understanding of what is science. Are we doing science now when we're predicting how much money we can make by giving people insurance or not? Are we doing science when we just tabulate everything for census data and we'll figure it out later? And then the birth of mathematical statistics is born of a set of concerns, as Matt already alluded to, in Victorian England, where the usage of data was really to figure out how can we make sure that everything stays as good as it is right now for those of us who are running the British Empire. So it's a birth of a field of quantitative racism. The person that gave us the word regression also gave us the word eugenics in the personage of Sir Francis Galton. So we go through like what are the interests of the people who are doing regression in early days and multivariate regression in the case of Ewell, who wanted to prove that giving people help would make them poor, or Pearson in the case of PCA, who was trying to come up with sort of the proto IQ test by figuring out why it is that people who had done well in classics should end up being the officers in the military.
Spearman, yeah.
Sorry, Spearman, not Pearson. Thank you. And then on to Fisher, right? So all of these things involve a rethinking of what even is science. So Fisher taking a lot of data and then also doing experimental design. So the idea that what we would now call an A/B test or a randomized control trial was somehow qualitatively different than just looking at people do what they do and then afterwards trying to figure out whether smoking causes cancer or cancer causes smoking, to build on other works by Fisher. As I said earlier, World War II is a tremendous breakpoint with the introduction of hardware, really. So we talk a lot about the physical labor. We talk a lot about women at the dawn of computing and how much of that labor was done by women, and just how even the dialogues that were happening about what was the valuable part of putting data on computers was argued for. A lot of this material is stuff that was classified until as recently as 2012. So we get to do some really interesting readings that rethink how World War II was won, for example, and also how immediately the development of the way we look at data on computers in World War II, particularly at Bletchley Park, went straight into the the NSA community, as well as the birth of artificial intelligence.
And so you have there both the creation, there's a large amount of data that's being systematically collected, the creation of information platforms that are for the collection and storage of data for the long run, and with the kind of Bayesian techniques that Turing and then his followers developed both inside the classified world and then in various ways outside the classified world, the creation of attitudes that don't demand any kind of causal model, because it just doesn't matter for cryptography. The development of some of these attitudes towards what you're doing when you're doing kind of statistical work are proved to be rather important for the subsequent development of machine learning.
Yeah, it's also a great intellectual breakpoint because before World War II, there's dominated by Fisher and Pearson and others and people who had data models and were interested in science and understanding things. And part of what you see in reading about Bletchley Park is like they just wanted it to work. They had to break the code, in the next 12 hours, and whatever worked, they were going to do. And so you see a real difference of the way what people think about when they're talking about putting data onto a computer. Okay, then we go into the birth of intelligence as a field. We talk about where the phrase AI came from. It's great to read the original literature and see how totally up for grabs it was to see how we were going to solve intelligence. Like today, people use the words AI, deep neural nets, and machine learning interchangeably. So it's really wonderful to go back and look at the literature and see how that is not at all what they meant. We introduced people to the first AI winter, which is a great story in the 70s about basically a fight for who should get funded. And as the promises of AI sort of didn't come to fruition as rapidly as everybody wanted, there's some great literature by scientists in a more traditional meaning of the word science arguing against AI as a thing. We talk a lot about the development of machine learning, and really it has the things that came to be known as machine learning now have a lot of roots in EE and pattern recognition and a lot of stuff that was funded largely by the military to, for example, find tanks in pictures. As we talk about the development of machine learning, we introduce them to a lot of the technical ideas that I would want even technologist students to know about, just at a high level, how to think about machine learning.
And because they've learned about Fisher and others, some of those models of mathematical statistics, they have a framework and understanding, as it were, the contingency and weirdness of thinking about knowledge as this. Just as they've thought about the contingency of weirdness of using regression and then later doing hypothesis testing. Those things have been contested, and therefore they're ready both to learn about these things and to understand a lot of the intellectual and then ethical choices involved in them.
Yeah. So if I were teaching a machine learning class, people would walk in and they say, "I've heard about machine learning. Teach me machine learning." And I would have to start with machine learning. But it's much more fun to be like, "This is why machine learning is really weird. Here's how people thought about data for 100 years before people started using the phrase machine learning. And here's the engineering things that they were trying to solve using this approach. And here's how now we break it down in a modern way." Then we start talking more seriously about ethics, because in the course of teaching them quantitative racism and other crazy things that people have done with data, the students occasionally raise their hand and say, this seems wrong somehow. How do we think about the fact that people were using multivariate statistics to argue for things that we would now find aberrant, or the early use of proto-IQ tests to distinguish people based on totally made up statistics. So then we try to give them some structure for thinking about ethics. And that brings us to a section that's more well known in departments like this, which is how do we define and how do we enforce ethics? And we try to make that clear that those are different things. So we introduce them to a history of, we've already introduced them at this point into a history of people doing things that seem repugnant in the name of science. And then we try to connect it with, okay, here's how we understand research. Here's to understand ethics in the academic research community. Now here's how we understand ethics in the case of practice and industrial practice. So an example that got a lot of attention was in 2014 when Facebook published a paper in PNAS proving that they could make you sad, and there was a big outcry about that. Oh, somebody brought up Kramer et al. This morning?
I didn't show the paper, but that's what I mentioned.
Thank you. And then we have to talk about, well, how did it get that way, that private companies are having such a deep impact on our realities? What are the business models that made that possible? We talk a lot about, once we've talked about ethics, then we can talk about how privacy and fairness fit into ethics as a rubric. We introduce them to some good literature, including from Communities as Weird as Law, where people have thought through carefully what can go wrong when you play fast and loose with the privacy around people's data. And just today and also last week, we were going through this example about what happens when you combine medical data and you make it anonymous because you take out people's name, but you also have voter lists available, which means you can do things like LaTanya Sweeney did when she was a grad student at MIT and she mailed the governor of Massachusetts his own medical records. So those were the sorts of things that led to a lot of regulation that we now experience. In terms of the structure, weekly, we try closely to pair lab work with readings, and we try to make every week a story. The story starts with reading, so we have some secondary reading and some primary reading, so we'll read the original work by Galton or what have you. And then on Wednesday, we fire up Python and actually look at their data. So every Monday is a reading assignment, we lecture and we discuss, and Wednesday we fire up IPython Jupyter notebooks and actually look at their real data. An example of a real notebook is here, where we did what Galton did by sort of simulating regression to the mean in terms of height distribution. So the idea for the whole week is we start out asking students to read something and comment on it in Slack, and then those comments in Slack are the basis for the opening of the lecture on Monday morning. And then we sort of give some historical understanding of what was the world like immediately before this intellectual advance happened. We discuss the intellectual advance, or secondary text, which helps students engage with it. Primary text, once the secondary text sort of draws their attention to what to look for in the primary text. And then we can talk about, well, how did that capability change the world in terms of rearranging power? And then we've already authored the Jupyter notebook, so they don't have to write original code. For students who don't know how to code, they can just press return and magic happens. But for students who know how to code, they can break it and interact with it more deeply. We try to construct a class with no prerequisites, in part because the code that we're giving out is pre-authored notebooks. It's not requisite that you know how to code in advance. And the reading level is heterogeneous, but because it's heterogeneous, there's no one group of students who already has the background in that one thing that we're going to dive into more deeply. We grade things in 2 tracks. So for people who are coming from a more humanist background, we ask them to do something slightly more technical. For people who are coming from a technical background, we ask them to engage more seriously with reading, writing. And as emphasized, the code is all done in Jupyter Notebook, or as I said here, code without any coding, because we're giving them pre-authored notebooks that they can work through. Okay, and then requirements which are less of interest to y'all than it is to people who are going to get graded. Ethics. So,
So let me
please.
ask before we get into that, do the students come out, the students do not come out knowing how to code at all?
And
Well,
that-
no, they
that
come
is-
out knowing, I mean, students who've had no background come out with some familiarity with using Python the way you can use it in a Jupyter notebook. That is typically manipulation of data, basic operations, the calling of methods, and other sorts of things. And we encourage them to, once they have those basics of manipulating different kinds of data types, to be able to use those. Some of them can do that at a higher level, and some of them, I mean, some it's very easy, and you can tell that some of the technical students are briefly, rolling their eyes at us. It's the classic issue of all general science education. But then we're going to ask them to do something with it. So I wouldn't say they don't come away with any structured introduction to programming in Python. They come away with some skills in what it's possible to do using a very high-level data science stack. And so the homework, they actually do need to put a lot of this into gear, and they find it somewhat difficult to learn how to do some of this data manipulation. They're not going to be doing, they're not going to be implementing SVD by themselves or anything like that.
But the glory of Python is you don't have to. So the very first thing that I show them in Python is import antigravity. How many people have ever done import antigravity? 0. Okay, it's a little Easter egg in Python. You can import antigravity, and it opens up this XKCD cartoon about how easy it is to do anything in Python because somebody's already written a module for doing it. So if you want to do SVD or SVM or anything, somewhere out there somebody's already written a module for it, and you import that, and kablamo, you're doing it. So for example, when we do Eliza, which is an early form of artificial intelligence chatbot, all you have to do is import NLTK, and Eliza's there. Same.
And I'll show you in a couple minutes how they gain enough literacy that they can look at some of this coding and understand some of what's going on. So the point is to give them some access. And if they want to learn more developed skills, they're going to be able to. But it's not going to there's no sense that we're fulfilling an intro CS
No, I
purpose.
understand that. I was just wondering how deep is their understanding get to? Is it they're familiar with some of the terminology, or they're familiar with a little bit more about what's really going on? Do they have a model of what's going on with respect to the computer?
It's not
really
requisite.
Just sort of an interface that you could do.
It's not requisite. I mean, those who are not.
I'm not asking you at prerequisites. I'm asking you at what they come out.
No, what I mean is you can get through the whole class and engage with the material and just press return. However, if you're pressing return, you probably get curious about the fact that you're having open square brackets 0. What does that mean? And the next time you do open square brackets 1. So I would imagine that students with a wee bit of curiosity will have the opportunity to engage and sort of break the code and see what happens, but it's not required. One thing I'll say about curricular mindset is usually when one is designing a class, you have to think about, well, what is the class they already took so that I'm going to leverage material which presupposes they took it, and what is the stuff they're going to take afterwards because I have to make sure that I teach stuff they need. We're liberated from all that. So we teach a class, and we don't press it, we don't advantage students who have taken a particular background because we're not assuming you have any particular background, and we're under no obligation to teach something to get them ready for 102 because there ain't no 102 for our class. Okay, so by the time we get to ethics, which we did last week, students have been uncomfortable all semester, right? We've been showing them technical material in a new way. Instead of just talking about the technical material, now we're going to invert a matrix. We're going to talk about, like, why was Ewell inverting this matrix? Why was Ewell interested in this? Well, he was interested in proving that giving people help makes them more poor, so don't do that. Great correlation causation conflation in the very first usage of multivariate statistics, by the way, in 1899. It's a great story. Ethics. How do we think about ethics? So, but at this point, they've been introduced to many, many dumpster fires in the set of the class, but sort of without any structure to think about, like, why does that make me uncomfortable? And how would I go about making a rubric so I could be slightly more analytic about what makes me uncomfortable there and how I might avoid it? So the way we try to show them ethics, one way to visualize our structure is we tried to make real clear the difference between how you define ethics and how you enforce ethics. So depending on how you're raised, when somebody says the word ethics, you may say I or B. And that's just sort of your reflex response to ethics. What we try to introduce them is to, again, it's a history class, so we're not adverse to going, okay, well, how did we get this way? Like, what was the ethical background that led to people even trying to codify, let alone enforce ethics? And we can do that by introducing people to the research conception of ethics, because that, at this point in 2018, that's a framework that's well known enough that even people doing industrial research are responding to it, right? In Kramer et al., there's reference to IRB. After Kramer et al., Facebook releases a paper about some sort of IRB light that they created at Facebook, and the title of that paper is Evolving the IRB, right? With the idea being that we're an industry, so IRB doesn't quite fit, but we will do something that's like IRB. All of this is informed by some sort of framework for thinking about ethics, and so we try to introduce them to that framework. That framework is implicit behind IRB, but who would ever talk about that? We just need to get past IRB. But we try to introduce them to why there's an IRB there and what sort of framework is there, because we believe that that framework is still useful, even in the real world.
And by stressing this dichotomy of defining and enforce, we talk both about, as it were, the philosophical foundations of ethical decision-making in different ethical models, consequentialism, deontological methods, other sorts of things, but also this really huge problem of enforcement. So the students are ready not just to engage about a debate about ethics, but really, is CS ethics going to go anywhere? Is that going to be like a business ethics course you take to fulfill a requirement and forget about entirely while you undermine people's mortgages for the rest of your life? So that becomes a serious a problem for them to think about, which helps to mobilize why, for all the people who hate IRB, why that's a very serious attempt to institutionalize and make real a series of ethical principles. Now, we may think it's the wrong one, but it addresses the question of enforcement very seriously in that context of the failures of the Tuskegee study.
We try to introduce them to an idea that ethics is granular, that ethics should be conceived of at different levels of specificity, because technologies change, rules change, but principles change less so. So this is a framework. If you look at Matt Selganik's book about doing social science research, this is emphasized. It's also, it shows up in legal theory. Like in legal theory, there are ideas that there are hard rules, like you got to be 35 years old to be president. And then there are more, fuzzy principles like the reasonable man test, which is a real thing in law. Would a reasonable man believe this? And so we try to first introduce them to the idea that there are some general principles which are then are hard-coded in rules that might be more specific to a particular use case and context. So what are principles? So principles that you might have heard about. Well, if you know about IRB's history and how it grew out of the Belmont Report, Belmont Report from the 70s tries to crystallize a large number of ideas into 3 general principles: respect for persons, which includes respecting their autonomy. Informed consent relates to that, because you can't make informed consent if you don't understand the experiment whatsoever or the product. Beneficence, so do no harm, and also try to maximize good and minimize bad. Justice, in terms of fair distribution of benefits research, and also protect people who need protection. And an augmenting of this it was from 2012 called the Menlo Report, which emphasized as well respect for law and public interest. Which also brought in accountability, which is the A of FAT, fairness, accountability, and transparency. I personally think that once you leave the research context and you move into the industrial context, you can make this even more granular. You have principles and standards and rules, and then eventually when you're running a company, you have objectives and key results, and eventually you have key performance indicators that a company will try to optimize. You see this quite a bit in the current debate around, say, recommendation engines. What actually is YouTube trying to optimize for, such that it's recommending these types of videos to people? It's unclear, but thinking about principles can give people a guide to thinking about more granular actions. An example of that granularity, again, this is taken from Matt Selganik's book, is when you think about how you distribute risk and benefit, think about, say, open release of data. If we release data open to everybody in our research publications, that seems good because it maximizes benefit by being in the public interest, because now everybody can get their hands on those data and do secondary analyses of it. But it's bad for the individuals whose data are in there, because it exposes them to all sorts of risk of privacy violations and anything else. So when you think about something like how open to be with data, you can see that there's the optimum is not necessarily on the extrema. That is, it's not clear that the right answer is just to give away all the data. It's not clear that the right answer is just to hold all the data to yourself. This is an example where you might want sort of some walled garden approach in which only certain people are allowed to have access to those data. To emphasize this in class, part of our lab was our own database of ruin. Database of ruin is this phrase from the lawyer Paul Ohm about creating data sets which might seem private, but if you have many tables with overlapping columns, eventually you can join the thing that doesn't seem PII with PII. So we ask students to fill out a little personal data about themselves, and then we show them, what other things can you get access to from these data? Once I know your zip code, what else does that say about the demographic background of your hometown? Once I know your uni, what other information does Columbia's LDAP system provide about you? There are audible gasps from the students when you see how much of their allegedly not PII data is actually a join key into more PII. Okay, which brings us to a discussion of what is the actual technology behind what we do. So we can walk you through the syllabus, but in the interest of time, maybe we'll just go straight into a little tech. So in terms of tech, as I said, we start out with Slack. So we give reading assignments about a week in advance. We assign to them that they have to contribute something to Slack. The students do contribute something to Slack, which leads to some dialogue, which is a great way to start out Monday morning lectures. Rather than me getting up and just opining, I can start with things that they say, and then I can call on them with more targeting and say, like, you said this comment, let's drill down there. We should probably also show some notebooks. So I think Matt has pre-selected some notebooks.
So I have a bunch of these. What are we doing on time?
I think until the top of the hour, maybe? Meaning you have about 10 minutes?
10 minutes. Okay. So Again, we have to start with no technical competence. And so we actually have students learn how to navigate a Jupyter notebook and then how to use it as a very simple calculator. For a lot of students, this is obvious. For others, they've never done this. But it also is available and possible for them in a way that they may not have encountered. I don't really want to spend a lot of time. But then the first thing we do after this is we have them break into small groups. And we ask them to go to the machine learning repository at UC Irvine and just pick any data set and start drilling down into it. And as a group, begin asking basic questions. Questions about how many rows and columns, what format is it in, are empty values noted, is the documentation any sort of good? They dive into it. Some of them are quite skilled at looking at it. Some of them just download it into Excel or are very skilled at that. But then we start pushing them to ask other questions about the data, provenance about it. And here, what you get again is the sort of the leveraging of the different capacities of the students. They start asking questions about who collected it and why. Were automatic sensors involved, and were human researchers, what were the assumptions behind the choice? If you have a column that has something to do with medical diagnosis, how is that going to be standardized and codified? What relationship did that have to clinical practitioners, and who was doing that kind of work? What was the processing? What claims about the representative the data is? And every single time we've done this, the students have found remarkable data sets and started to realize quite remarkable things about them. You have some favorites.
Well, this time they found a bunch. For some reason, two of the groups chose data sets about wine, and another one chose a data set about, I think, birth control in Indonesia. And then, so we use those data sets the next week to start saying, okay, how do you explore a data set in terms of exploratory data analysis? So we took the particular data sets from UCI database that they had chosen as being interesting and saying, okay, let's drill down more into those data sets in particular.
Yeah, and one group, not this year, last year, did this. There was this thing about horse colic. And it caused quite a remarkable conversation about how is a clinical diagnosis built into this data set, which is used all the time in the machine learning literature with total disregard to its subject matter. So from the start, they're learning about the constitution of data and the fact that none of it is born pure or free. Now, we do a lot of different things. Another lab, a couple weeks later, we look at the great Belgian historian Quetelet. And Quetelet effected a massive transformation in how you could use the kind of theory of understanding error and observation from Laplace and Legendre and other people like that, transformed it into an account of human variation. And so we give them substantial excerpts from Quetelet's text, which is written for a relatively popular audience, and then we work them through his introduction of the normal curve as something to being understanding, and the way in which his text moves rather problematically from a philosophical standpoint, from an argument about making many observations of a single statue to making observations of an entire army. And so we work them through this data set, we ask them how this gets produced, and then they begin calculating with it. And then they come to being introduced to some basic methods of doing data analysis. And then we end where we return to a very challenging reading they did about this fundamental epistemic transformation from data and, the theory of errors to an account of human normal variation. And so it's very much attempting to break through a divide between, as it were, the techies and the non-techies in a productive way. A few weeks later, we're introducing them to, as you've seen, to several different stories about artificial intelligence. And so in this case, we wanted to talk about artificial intelligence before or in parallel to what we think of as machine learning now. And so we have them take a look at Eliza, which surprisingly not very many of them had encountered. And the remarkable thing about Eliza is that it's very funny, and Chris wrote some has very funny conversations with Eliza. But the students have enough capacity that when let me find it here, we can look at the source code, and though they're not fantastic programmers, many of them, the source code is so straightforward that they learn to they can recognize quite quickly, and they say that if you type "I can't," Eliza is going to pick one of these pre-programmed answers. And so it really introduces them to a certain kind of rule-based AI, which was, of course, of tremendous importance. And we continue this by asking them to, we did ask them to produce a chatbot of the figure animal, but it turns out no 19-year-olds know who animal in fact is. So this was a massive failure, unfortunately. But then we push further than the sort of trivial example of animal to look at the expert systems moment, and one that I know some people in this room know tremendous amounts about. But the idea of knowledge engineering and the extraction of knowledge from clinical knowledge. And again, we introduced them to the problem, the challenges of the microbial revolution, the constitution of something that involves domain experts and knowledge engineers. And again, though they're not sophisticated coders, the way we have here a tiny bit of Mycin written and translated into Python, in which they can see the hand-coded quality of the rule and see the ambition of the expert system, but also the profound challenge of hand-coding all of these rules. And then just as another example, a few weeks later, we're looking at the creation of recommendations engines and databases, and the dangers and positive capacities that are made possible by the constitution of databases, the greatness of the long tail and the introduction, the ability of people to communicate. So we give them this famous article from Wired before talking about the Netflix prize, and then we teach them about relational databases, and then we build a very terrible recommendation engine in real time, and including all of the kind of subjective design choices. So how do you deal with the fact that tons of people haven't rated the movies, or the fact that there's a certain amount of people that hate everything and there's a certain amount of people who love everything? Like, there's no obvious way to do this. So these, again, it's a very easy level of programming, but we can do this interactively in class. I'm sorry, I'm just going through this. And then to turn, we introduce cosine similarity, and then we can return, I'm sorry, this is very long, to the Netflix challenge. And the way in which that captured both socially and in terms of the transformation in the last 2 decades towards ensembles of teams, but also ensembles of models, and the way in which that indicates a kind of series of attitudes within machine learning and within certain dimensions of computational statistics in which the constitution of an interpretable model is not necessarily the goal. Before ending with precisely the dumpster fire of the Netflix challenge being de-anonymizable. Just today, and so I hesitate to show this to you because like this literally got written at 1 a.m., we wanted to actively get them thinking about questions of fairness and the fairness, accountability, and transparency. We introduced the two key legal accounts, disparate treatment, which is basically the deliberate exclusion of people procedurally. So that is deliberately excluding, say, a particular race or sex from joining your club, from desperate act, which is about outcomes, regardless of thing. And these are enormously important in the fairness literature, as many of you probably know. And then we do it. We load a data set. We show how easy it is to take a data set that shows economic, racial, and sexual stratification in the United States. We build a predictor. The predictor duly predicts all that bias. We remove race and sex from it. The predictor still produces race and violence, still produces that bias. And then we leave with the question of what is it that we are going to do then? And the students have enough sophistication to look at the kind of trade-offs that Chris was just talking about between predictive accuracy and the other demands that privacy. So we have labs throughout that are just like this. And in some cases, the students can literally click through. So I say, here's how you do a decision tree, and here's how you do a random forest. But there's also queries along the way where we pause, and we're like, we did this, now it's your turn to figure out this. Early on in the semester, that's like, how do you find a mean? Can you make histograms? Can you do scatter graphs? The students who have no technical background find out that those fancy diagrams their other students have been producing in class are now sub-trivial to produce, and they're no longer as impressed. But they also learn to recognize that the tuning of those and the subjective design choices are a very serious thing that leads them to that kind of critical literacy, which even if they don't have profound functional literacy, they have more of an understanding of the significance of the choices that have been made by, say, these particular Python implementations, and our choice to go along with those or not. Anything more about labs that you want to? So we have lots more. We have a lab where they have to reproduce some of the things that Turing does, and a Bayesian intro to cryptography and other sorts of things. But maybe we should stop here and answer any questions.
Please.
Interrupted at the beginning to ask you how you learned how to use the Facebook capabilities for purchasing advertising to your. It's not easy. I've found. I've actually played around with it myself.
So.
Just teach yourself, or did you find a manual or something?
I did a sabbatical from Columbia in the fall of 2013 at the New York Times. And since then I've maintained a relationship with the New York Times. And one of the things that the data science group at the New York Times has worked on is deep API integration with Facebook's marketing tools. So I actually sat down with a senior data scientist who knows his way around the Facebook API.
So much better.
And it was he that introduced me to the Power Editor in the first place. So I had a guide who descended me through the levels of Facebook's marketing.
I just ended up in hell without a guide and paid $50 for it.
But you know, these companies make it very easy for you to get out your credit card and give them money. So in the example of Matt and Twitter, it was precisely because Matt did not descend into 7 levels of digital marketing hell, but rather he had put, gotten his credit card, given Twitter a little bit of money, and Twitter said, hey, don't you want more eyeballs? And he clicked on something and said, sure, more eyeballs, please. It said, great.
Yeah.
Here's 6,000 eyeballs in Indonesia.
Right.
That'll be $50. That'll
Like
be $50. Thank you. Please.
I'm curious, it's probably really easy for me to look this information up on the Columbia site, but how enthusiastic are undergraduates about the sports work you're describing? Because obviously people in this room are really passionate about data and studying data, but I'm curious how younger students earlier in their career are, enrollment-wise.
Enrollment, I think we did ourselves a disservice this term by having it at 8:40 a.m. So
Yeah, this was definitely a mistake.
we started out with 40. I think we're now down to somewhere in the high 20s. I mean, non-quantitative metrics, I don't know, people are really bothered by this stuff. You know, you certainly get audible gasps. And then when Zuckerberg testified, they wouldn't let me get to my material. They were like, can we talk about Cambridge Analytica now? So they're definitely interested in the material.
Yeah, and the engagement comes, last year was really marked that we had a room, we didn't expect it, but most of the students came from very serious CS and machine learning background. And so they were treating the class almost as a kind of capstone that united a lot of the humanistic concerns they'd had at a liberal arts college with very serious technical chops. And they were a great audience. But then there were as many students, there was a smaller number last year, but this year it's more balanced, of students interested in policy and history and other sorts of things who know this is something they both need to understand at some basic level and that they need to engage with. Now, what we haven't done is gotten it through all of the administrative processes to make it a requirement for anything. But once it does, if it were to become a larger class, that would be extraordinary, but where exactly we would get teaching assistants is really a mystery. When you fall between not only schools and departments, but the kinds of competencies we're asking for are highly unusual for any one person to have. So I think it will be a great experience for the TAs, but scaling this is a non-trivial problem. Some of these assets we've created, these are designed to be scalable. The way we're running it as a discussion section, we're lucky that we have a group of 30 students because you can have a discussion. I think as it gets bigger, and I think it will, we are going to have to move somewhat begrudgingly to more of a lecture style for at least the first part.
Please, question.
When you look at Slack and the comments that people post, what kind of themes do you see that people are interested in? Is there something that comes up as
Depends a lot on the student, just like the iPhone versus neoliberalism thing. There's some students who always want to tie it into their own personal work experience. So like there's at least 2 GS students who have actually worked in companies where data was relevant, and they often bring up their own personal experiences. I don't know. Different students bring up the same themes repeatedly, and also it changes by week. So again, Facebook appears in front of Congress, and all the questions are about like creepy social media stuff. Older stuff about quantitative racism, people are about stories that they say in the media today about use of data to reify and reinforce racism. So it changes from week to week and from student to student. George.
Are clicks and eyeballs, is that a relatively stable thing, or is that transient? We know it lasts forever, but is that something that we're going to see for a while, or is it going to flop into, like, is that the right stable structure for managing the economy? Actually, then the other question I was going to ask Jeanette earlier, we didn't have a chance, was is there going to be a backlash where as people see this course gets more disseminated, will there be an insistence on doing things in person and only trusting people until we produce androids, and then I guess you can't go there either?
George, you really overestimate my predictive power, because I remind you that predicting is hard, particularly predicting about the future. One of the, in terms of clicks, when I think about clicks, I think about the famous phrase misattributed to Einstein, not everything that counts can be counted, and not everything that can be counted counts. Clicks are extremely easy to count, right? It's easy to turn it into a SQL query. If you're in any tech company, you figured out how to log events, and there's going to be some SQL query where I can figure out how many people clicked on things. That is a very easy to measure KPI. It's also something that in the advertising model sells. It's very easy to convince marketers, you should pay me by the click. So there's a lot of institutional and economic forces to keep clicks in business as currency. In terms of what will happen, I like to think about the story of seatbelts. So mass production of automobiles started around 1916. If you don't wear seatbelts in an automobile and you have an accident, the consequences are graphic. And yet there was no meaningful regulation around seatbelts until the 1960s or so. Social media has not been around for nearly that long. When something bad happens to your personal data, or you end up sharing something from the Internet Research Agency in St. Petersburg, the consequences are invisible and not graphic and probabilistic. So I don't foresee a large-scale regulatory effort to protect consumers, but anything is possible. That's why I like this. Matt has heard me many times talk about the metaphor of a three-party game among private companies, the government, which is allegedly setting the guardrails, and the market, which decides where they're going to spend their money and their attention and their talent. So, anything has happened. If the market decides that, irresponsible use of private data is untenable and rejects those companies, then those companies get rejected, right? The actual assets of a company like Facebook are large, but not nearly as large as their valuation, right? The thing that makes them valuable is the fact that people continue to use them. So,
I want to add to that.
please.
So I don't predict the future either, and I actually think, for instance, Mark Zuckerberg would have got away with it, unfortunately,
In front of Congress? Yeah.
Testimony to Congress really, to me, showed how, unfortunately, our congressmen are not very technically literate, and so they don't even know what to regulate, or, let alone what the regulation should look like. And so that was a lost opportunity if they actually wanted to get educated and really threaten Facebook or Mark. So I don't see the current climate. I think it's the market forces. I think Chris is right, because I don't think we can expect government. I mean, government might do something, but I'm not sure they'll know what the right thing to do is, or what they do is going to be good or appropriate or meaningful. But I do think that, since I do research in privacy, it was always one of these things like, why do you do research in privacy? No one cares about privacy. And I'm always like, well, all right, well, I'm just going to do the tech that we can do. So as long as people are willing to sacrifice privacy for convenience and all other sorts of things that they don't realize they're paying for, maybe nothing's going to change. It's hard to know.
So the students are reading about the attention economy for next week.
One other thing
Oh,
I
yeah.
want to add, and that is, people were picking Facebook. But what about Google? And Google has tons more information about all of us. And we're not picking on Google. And Columbia makes us use Gmail. And it's like, we don't even have a choice about that. So, I don't know. Some of this is out of our hands.
So yeah, having fought the uphill battle about Gmail with CUIT for many years, but one thing we're giving, in the last week, we're giving students some essays on the attention economy, precisely because there's such a fundamental lack of literacy, even among both in the technical and the humanist community, about what is it that you are worried about being scarce. And so it's not just the senators that are illiterate, like they don't even know what it is that Mark is trying to optimize for. I think what we don't, the end takeaway, we don't have a perfect picture for them, other than we don't want to end with just like, here a Luddite, here's all the dumpster fires of the data sciences. Because that's just kind of, it's easy. And there's a lot of books that end that way. We're like, what are the tools that we're going to have to think about the different layers of this response? And some of those, as we said, are ethical and philosophical, that have important, really important things, like to be a consequentialist and be interested only in, say, the average increase in GDP is one position that's quite different from being one that respects the dignity of every single person. And that's at once a philosophical position, but then it ends up in your KPI. And to get the students to recognize that, but then to go from those philosophical principles to what are the levers that are available to us. Regulation is one very blunt one, and blind faith in market forces is another. But what is going to be the package of things that is going to come? I don't think we quite have the best way to present them, but we want the students walking away thinking about what are the levers going to be? And how do those levers not fall into sort of easy political boxes, because that just doesn't seem to be very helpful.
Let me tell you the 4 assignments we gave them due Monday. First is a video from 1973 by Richard Serra that, as far as I know, introduces the phrase, "you are the product," in the context of advertising. So I want them to know that the idea that you were the product was not something that was invented last month. The next is an article on the attention economy from 1997, when people realized what World Wide Web meant. It meant that your attention was going to be scarce, and there's going to be a whole economy built up around it. The final 2 pieces come from last month. So last month is a piece written by a law professor at Cornell Tech about fake news, the last sentence of which is, it's not just that the platforms are broken, everything is broken. So that's sort of a downer. And then the fourth piece was written last month by a venture capitalist. And the final quote is from Marx about the importance not just of understanding things, but of changing them. So we hope to end them with some optimism about what are the forces that actually cause tech companies to change. Please.
So I have a question about your thoughts on the sort of distribution of responsibility for critical examination of technology and data science and AI between different disciplines, and your choice of teach this course between two different schools and also have a diverse body of students. There's a conversation going on right now at the Future of Computing Academy where a bunch of junior researchers proposed an idea to change the peer review process to require researchers in technology to critically examine potential negative consequences of their technologies. So that generated a huge discussion, part of what was a response from a non-technical community suggesting that perhaps technologists are not the best equipped to critically examine them, and perhaps we should be asking historians and social scientists and philosophers to think about that. Do you think that the kind of course you're teaching can raise and help new generation of techies develop enough of a critical acumen to become the critics of their own work? Or do you think it might help them to build stronger relationships with historians and philosophers? How do you see this developing in the future?
The answer to your first question is yes. The answer to the second question is everyone should take our course.
Yeah.
People should know that. I don't believe that it's such a foreign and difficult concept that you can't teach ethical principles. And I don't believe that technologists are unable to learn ethical principles, right? There are habits of mind that technologists have. They approach a system and they think, how am I going to model it? Maybe I should start writing down a Hamiltonian. Or how am I going to model it? Maybe I should start thinking about what terms are large and what terms are small. There are habits of mind. Ethics and thinking about things in terms of principles is a habit of mind. Even before the principle you raised, people have also proposed that every paper should have an ethical appendix. And that means that you should think about, say, the 3 Belmont principles or the 4 Menlo principles and just enumerate how will your subjective design decisions relate to those principles. It's just not that hard. Right, it just becomes a norm of the community, and you shame people who don't do it, or perhaps you don't give them funding in the same way that or don't allow the paper to be published in the same way you can't publish without putting your coordinates in PDB or something. You know, there are like changes that a community has to enact. Sometimes the gatekeeper is the funder, sometimes it's the publisher, sometimes it's the university. But those are changes in norms for which there are institutions that make sure that those changes happen. I don't think it's epistemologically impossible for somebody who knows science also to be able to make some small accounting of how their individual subjective design choices related to a small handful of principles. And
so when we teach the students about things they often know, so about hypothesis testing or about Galton, a lot of the students, techie and non-techie, have taken some of those things, but they've read them typically in a statistics textbook that does not mention eugenics or does not problematize hypothesis testing as this radical transformation of the way we thought about science. So for the more technically advanced, we use that as a wedge to get them to thinking about these subjective design choices. And on the flip side of it, the less technically motivated students who, say, are more comfortable in different forms of social scientific contextualization, they often are lacking any granular knowledge. So there'll be this sort of like, you'll see a lot of statements in the kind of fields that I come from in science and technology studies as if there's this sort of undifferentiated AI, which has no sense of where machine learning differs from mathematical statistics of 50 years ago. And so by being insufficiently technically granular, it's not able to give it's not able to be very helpful whatsoever. And a lot of the most interesting work is coming either at collaborations, such as ours, or by people who are in settings where they can get those multiple competencies. Like Chris, I think everyone should take our class. Oops. Oh, I'm near the speaker. Please.
I haven't totally thought this question out, but I found what your discussion about intention to be very interesting. So, you know, there's capability with new technologies to do good or to do bad. People might give their health data freely if they think it'll help them get a better diagnosis, but they don't want to give their data if someone's going to monetize it. So in terms of, you know, the capability of technology doing good or bad, and discussion around regulation, you know, if they knew more, they would, I guess the question is your thoughts on, is the regulation around controlling the technology, or does it more have to do with, you know, punishing or rewarding intention? It's a little bit like guns, right? So guns could be good or guns could be bad. It's a tool, just like this might be. But it's the intention. Do you want to use this to, so what is your thought around regulation with respect to controlling this, what people give, you know, trying to set it back by not collecting as much data or limiting the capacity of this data versus forgetting all that and punish people who are doing bad things with something that could be good. So it's a different sort of paradigm of regulation that doesn't hold back something that could really do good.
Well, there's a lot to work with there. So that observation has in it defining ethics and enforcing ethics, but mostly enforcing ethics. And when it comes to regulation, a lot of regulation is about making sure that bad things don't happen. So sometimes it's punitive, but usually it's preventative and sort of about compliance. I guess my thinking about that is that it's wise for people to understand things at the appropriate level of granularity. Like if you make things too specific, then the rule doesn't even make any sense. 3 years later, for example, a well-armed militia in the late 18th century probably meant a very different thing than we could imagine a regulated well-armed militia may be something different from the 18th century from in 2018. So I do think some awareness of the principles from which the standards and rules are deriving would be useful in general for regulation around technologies. We do try to emphasize the capability and intent thing was earlier when we emphasized this phrase from some Google Eye researchers about technology. And I said a technology separates a capability from an intent, whether it's a gun or multivariate regression or a hammer or any other thing. Usually these capabilities are developed by a technologist who has some sort of utopian vision of how somebody will use that technology, like an internet or an email. And the person who invents email is thinking about communicating with other people and not about spam. So yeah, I mean, I think in general the story of technology is a story of that separation between capability and intent. Responsible use of technology includes thinking through possible usages of that technology, but the limits to consequentialism is, you know, we all have finite capability for thinking about what bad things people might do with a new capability, and in fact, as the system changes, as the whole system changes, new consequences will come into being that didn't even make sense when the technology was first derived. So part of what we'd like to teach is responsible creation of technology also involves monitoring and mitigating risk as people deploy a technology, particularly when it's something like software as a service or you know, your news feed, right? It's actually very easy to monitor and correct for malusage, adversarial usage in a way that like recalling a gun or recalling a car is actually much more difficult than changing the parameters in the news feed, right? So I think that's how we try to teach it. But both, there's regulation, but again, there's the technologists themselves, right? Like we'd like for technologists to think of ethics as not an insurmountable barrier, right? It's reasonable to be aware of a few principles, and when you make subjective design choices, to reflect on how those subjective design choices meet or conflict with a few principles. Please.
So I'm just wondering if the students ever come up with this argument that I've heard from Gerald Lanier, the idea that it's not an issue of privacy, it's an issue of value. So your data is valuable to the company who makes you the product. So why don't we charge for the data? Or make that the privacy choice. I'm willing to give you my medical record if you give me money.
I haven't heard our students. I've certainly heard other students come up with that. building on your comment and also Jeanette's, there was a lecture by Eben Moglen at NYU in spring of 2010 where he gave a lecture called Freedom in the Cloud, and he said, we all get free documents and free email, and in exchange we get free spying on us all the time. And that's what led 4 students to go try to create Diaspora, an open source alternative to Facebook. So certainly it is the case that some young people, when presented with the fact that their data are valuable and somebody else is monetizing it, try to respond by shaping a different future. It hasn't come up very much in our class.
I mean, if a student were to raise this, and it's a very powerful way of thinking, and it could have powerful political and economic pull, right? I mean, throughout the class, we want them to think about different forms of value. And to think of privacy in terms of monetary value is a really narrow conception. Now, it may be the one that is best operationalized, like having a long discussion about autonomy is enormously important, but perhaps that is not strategically a good way forward. So I think there's room for conversation both about the dangers of such a narrow version of privacy and the way we might tactically or strategically want to change for legislation. Like, our goal might be really the possibility of data sciences for enhancing autonomy. That's not going to change regulations, but we may be able to change something by talking in almost pure Milton Friedman speak about value and then get somewhere. That's, I think, a completely plausible thing. I want to encourage students to sort of fight that out. Yeah.
I have an erratum. So hearing Matt's answer, I realize now what I should have answered, which was they will next week. Because for their reading this week, they're reading The Attention Economy, which is all about the value of their attention. And they're reading this essay from a venture capitalist about the forces which constrain innovation, which include the market, right? Like us, right? We make choices with our attention. Those of us who go work for these companies make choices. Do we choose to work for Google or Facebook or something else or not? So actually, after next week, rather, I think the readings will be much more guiding them towards thinking about the value of their own attention, clicks, what have you, and how they participate in shaping the unstable game. Okay, thank you, Noemi.
Thank you.